So maybe the most difficult thing about exponential equations is figuring out how to start. So I've got three different equations here. We're going to look at each one, and I'm just going to talk through the process of how to decide what to start. So let's look at this first one. You've got a situation where we've got three terms, which is not a good thing. Usually if you have one of these, it's really nice if you have one thing equals another thing. But we've got three in here, and that's going to be a problem because I don't see a way to combine them. You might want to think, oh, we've got a base 3 here and a base 3 there. We can just add those together somehow. No, they don't add together because they're exponential. However, what we do have is something squared, something not squared, and a plain number. And that sounds like a quadratic equation. So let's see if we can get it to look like a quadratic equation. So if I rewrite this, so now I have something that looks very much like a quadratic equation, except instead of x, I have 3 to the x. Well, I can fix that. I'm going to use a u substitution. U substitutions are used very frequently in math, so it's a good thing to learn. We're going to let u equal 3 to the x power. Now our equation looks like this, and that's definitely a quadratic equation. I can rewrite that with the 6 on the other side, and we know how to solve these. This is u minus 3 times u plus 2. So u equals negative 2 and 3. And we're going to look at each of those separately. So u equals negative 2. We need to solve for x, not u. So we need to use this fact over here and take things back into x's. So this then becomes 3 to the x equals negative 2. But exponential functions don't have negative 2 in their range. So negative 2 is not in the range. So no solution. And what I mean by that, if you look at the graph of 3 to the x, you'll see that there are no negative y values that go with that. It can't equal a negative. So let's look at the other one. That's u equals 3. Then we have 3 to the x equals 3. Well, that's easy. X has to equal 1. And that is a viable solution, so this is our answer, is x to the first power. Let's just check that, just for fun. So we have 3 squared minus 3 equals 6, and that absolutely does check. Okay, so that one wasn't too bad. Let's look to the next one now. Okay, we're going to work on this one now. And let's take a look at it. This time we also have an x squared, a plain x, and number. Maybe that's going to turn into a quadratic equation. Let's see if I know, because they're not really adding together correctly for that. I've got this multiply in here, but I can see that these are all powers of 3. Let's see if we can solve this by turning everything into a power of 3. So if we have 3 to the 5x times 3 squared to the x squared equals 3 cubed. Let's see how that works. 3 to the 5x times 3 to the 2x squared equals 3 cubed. So if you remember your exponent rules, there's one that looks like that, and that's our situation here on the left. So that becomes 5x plus 2x squared. And now we have things with a like base on each side. So those bases can just go away, and we can just solve this. And now we're down to that. And you can use the quadratic formula on that, or use the AC method, or whatever you like. And to solve that, I forgot my squared here. Let's draw that on. But you will find out that x equals -3 and 1. So we need to do a check on these because sometimes we get extraneous answers. So 3 to the -15 is our check. And we have times 9 to the 9th. Does that equal 27? And I'm going to switch that 9 to the 9th back to 3 squared to the 9th. And yes, it does, because we have 3 to the -15 times 3 to the 18 equals 3 cubed. And again, you add those exponents in this situation, so that does check. If we check the other one, so we're looking at 1 now, we have 3 to the 5th times 9 to the 1st. Does that equal 27? Well, no, obviously not. So this is an extraneous solution. So our answer here is going to be -3. And let's look at the third equation now. So here's our last equation, and I'm looking at it, and the good news is I've got one thing equals one thing. I don't have an extra number floating around in there like I did on the first one. Not seeing anything I can really make into a great quadratic equation here because I've got different bases. So I can't do a u substitution without having the same base. I could write this out as 3 to the x times 3 equals 5 to the 2x times 5 to the -3. Do I want to do that? No, that's not really helpful. So no, let's not try that. So let's just go with inverse functions. I know I've got to get those x's out of the exponents, and to get something out from inside a function, you use the inverse function. I'm going to use one of the ones I have on my calculator. So either natural log or log base 10. We might as well use log base 10. So I'm going to take the log of the left side and the log of the right side. This is equivalent to taking the square root of both sides of an equation. It's completely legal to do. Now I'm going to use one of those exponent laws where I bring the exponent out in front of the log. I have to use parentheses here because this x plus 1 has to be multiplied. The whole thing has to be multiplied by log 3, not just part of it. So I really need those parentheses. And now what do? I've got x's on both sides. It looks messy, but I can do the distributive property, so I'm going to go ahead and do that. All right, and get all the x's on one side. That's what it's good to do whenever you are solving for x in general. And I can factor out an x. This looks really messy, but x is the only thing in here that's not a number. That you can put these things in your calculator and get something out. So and no, that does not reduce. This actually is your answer. If you want an exact answer, if you were doing a word problem, you'd put that in your calculator and get a number for your answer. So that's that one. Hopefully this has kind of walked you through how to look at a problem and analyze it, see what you can, see what tools you have will work on it, and maybe try a few different ways like we did this time. We tried that way and went, no, I don't really like that. That's not really too helpful, so we tried something else. So hopefully that will help you analyze a problem before you start working on it.